Hey guys, so I'm a little sick, so I might sound a little funny as I go through this, so I apologize. But you guys are doing 9.2 notes number 1, and the learning targets are all about finding area of different shapes. I'm pretty sure you're capable of reading them yourselves. So the first thing with area that it's really important to remember is that area is represented in units squared. So what I mean by that is if we have like a 3 by 3 square, so it's got 3 and 3, and so when we do that and create the actual squares inside of it, oh sorry, and these are 3 inches, so that means we have 9 of those boxes that are an inch by inch, which means inches squared, because something times itself is squared. Just like we could say 3 times 3 is 3 squared, same with the inches. So I would do my 3 times 3 gives me 9, and we would say that that's an inches squared. And the thing that I hear the most that drives me crazy is you guys want to then square the 9. No, it's just the inches are being squared. It's telling you that it's an area and that it's a technical thing to do. So don't square the 9. The inches is just squared. It's just a notation, alright? And you need to get in the habit of writing that. So when you give me the answer to an area problem, you need to make sure that you have the units squared. If you just put it in inches, it would technically be wrong. It's inches squared. Alright, so the next thing, the other day you guys found all the formulas for these, so we're just going to write them down to have them in your notes and do a few problems with it. So and sorry my notes look weird by the way, it's just the way I had to get it with this program. So with a rectangle, a parallelogram, and a rhomb, and actually the rhombi is actually an error. I need you guys to cross that out. That's going to come up later. It's just, I make errors. You guys are used to it by now. So with a rectangle, so if we have our rectangle here, we label rectangles by their length and their width, and they for some reason use cursive L's, and so I've gotten the habit of doing it as well. So we'd say the area for a rectangle, actually let's write that inside of here. So the area formula for a rectangle is just length times width, which you guys should know by now. And it's the same with a parallelogram. So for a parallelogram, here's our parallelogram, and we usually draw the height for a parallelogram inside of it, and it has to be perpendicular to its base. So that's why you'll often see a little square there. You guys should know that means perpendicular. So that is the height of the parallelogram, and this would be the base, and so the area, it's technically the same thing as saying length times width, but we say base times height. Just because height is more technical because it's having to be perpendicular to the base versus, which technically it is on a rectangle if you think about it. That's obviously a right angle right in there. It's just for some reason they've decided to do it in base times height versus length times width. So for our shapes down at the bottom, for example A, if we say this side is 6 feet and this is 9 feet, the area would be 6 times 9, which would be 54 feet squared. Then for a parallelogram, if we say that this is like 10 centimeters and this is our height is 5 centimeters, you would do 5 times 10, which is 50 centimeters squared. Okay? And if you need to write that out, that's fine. Sorry, I got lazy there. Okay. The next one is triangles. So, as you guys remember, that triangles are related to the rectangles. They're just half of the size. So no matter whether we have this kind of looks like an isosceles triangle, but no matter the shape of the triangle, they're all triangles. So no matter the type of triangle, whether it's an isosceles or a right or a scalene, these triangles all need to have their height be perpendicular to the base, just like with the parallelogram. And so we would say that the area is equal to 1/2 base times height. And some of you prefer to do, sorry, that's supposed to be an or area equals base times height divided by 2. Those are the same thing, so you guys need to get used to that. Dividing by 2 and multiplying by 1/2, same thing. Okay, and just because it's going to come up on a worksheet, and I want you to be aware of it, if you have a triangle that's kind of all skewed like this, they may put the height on the outside and show that it's perpendicular, and that's usable. It doesn't always have to be inside the triangle like that, but it has to be perpendicular to the base of the triangle, whatever they consider the base at that time. So for our examples down here, if I say that this is 6 inches and this is 14 inches, and this is it's a right triangle, so there's our right angle. So we would do 6 times 14 divided by 2, and that gives me 42 inches squared. And for our next triangle, if this is like 16 centimeters, and our height, then that's a little off. Our height inside here is 9 centimeters. We would do 9 times 16 divided by 2, and that equals 72 centimeters squared. Alright, next, trapezoids. So trapezoids formula is area equals 1/2 times the height times B1 plus B2. And so just to have a reference here, our trapezoid, this would be B2 down here, this would be B1, and our height again has to be perpendicular inside, so that's our height. So B1 and B2 is just the two bases is what we call it. Yeah, okay. So for our examples, if this is 6 and this is 2, and our height inside it is 3, we would do 1/2 times 3 times 6 plus 2, and we have to follow order of operations, so that means we need to do our 6 plus 2 first and get 8 times our 3 times our 1/2, and then we can just put that in a calculator, or well, you should be able to do it in your head. The 3 times 8 is 24. 24 times 1/2 would be 12. And I just realized I didn't put units on that, but I think you'll survive without them. Alright, our other one, I'm kind of realizing now that 2 examples for each one's a little overkill, so sorry, but I'll just keep going. So we have 10 inches for our one base, 9 inches for our height, and 13 inches for the other base. Sorry if you hear me sniffling, I can't help it. 1/2 times 9 times 10 plus 13. Add our 10 and our 13 to get 23, times 9 times 1/2, and that equals 103.5 inches squared. Alright, kites. So, and if you notice on here, there is a correction. So kite and rhombus, this is where the one got scratched out, and this is where it's supposed to be. So with kite, because a kite and a rhombus. So I'm not sure if you guys remember, but so our kite, you guys know that shape. It's that. But a rhombus. Okay, so rhombus has equal sorry, equal sides. It's like a parallelogram with equal sides. So yes, they could have a height and a base, and you would just use the formula that you would for a parallelogram, but they might give you the two diagonals, and if they give you the two diagonals, you can still use the formula, or you can use the same formula as you can with a kite, which is why I put it in here, just in case they do that. So in this example, I put just a kite though. So our diagonal is, oh shoot, sorry, I'm really not feeling well, so sorry for all the like crappiness of this video. The kite of the area, the area of the kite, is 1/2 D1, D2, which means diagonal 1 and diagonal 2. Okay, back to the example. 19 is that one, and this diagonal is 12. So you do 1/2 times 12. I wrote 19, and there we go, 12. Alright, so we do the multiplication, and we get 144. Alright, last one. Circles. The area of a circle is pi r squared. So really the only trick to this is make sure you're using the radius and not the diameter. And sometimes they might ask you to leave it in terms of pi, and I'll go over that in the example. So, for example, if we say this is a radius of 6, we'll say feet. So you're going to do pi times 6 squared, so that's pi times 36. So if I left it as pi times 36 or 36 pi, that's leaving the answer in terms of pi. Most of the time I'll want you guys to give me the approximate answer, so you'd say that approximately this is 113.09, and it'd be feet squared. Okay. So this one, the second one, if we have that this measurement's 9, that 9 is the diameter. So you need to get the radius first. So you would remember that the diameter and the radius is half the diameter. So you do 9 divided by 2 to give you 4.5. And then you would do pi times 4.5 squared. And so then when you do that, you get that it's approximately 63.6, yeah, because I didn't give you guys any units, so. Alright, that's it. So then you guys just need to do your assignment that's on the next 2 pages. Chris has the information. Okay.